find an equation for the line, tangent to the curve at the given point. So this is my curve, and in order to find the equation of the line, I need to find the slope at a given point. And what is the slope? Well, the slope is the derivative, D-E-R-I-V-A-T-I-V-E. The slope is a derivative. So I need to first find y prime, and then evaluate it at x equals 1. That will give me the slope of this curve here at the point x equals 1. Once I do that, then I will have a point. So I can find the point, and I will have the slope. And I will be able to use the point-slope form of the linear equation to find the equation for the line tangent. So before I start, I'm going to do my little cheat sheet here. I'm going to say that this is function f, and this is function g. And I know that I'm going to have to use a quotient rule, so I know I'm going to have some form of f times g minus some form of f times g, and it's going to be all over g squared. And I just take my little derivative symbol, and first I started at the f, and then I started at the g. And this is a helpful way to do it because sometimes you're going to have even more than one to find the derivative of, and I just kind of keep moving it 1 over. So I want to have f prime, so I'm going to write this here. I'm going to write x cubed plus 1 prime. I want the derivative of that times my g, which is 2x. Then I'm going to subtract from that my f. Oh, I need to get some room here. Subtract from that my f, which is, put in brackets here, x cubed minus plus 1 times the derivative of 2x. See? F prime g, f g prime. The prime didn't move over with it. So that's my gap there. And that is all divided by 2x squared. Use your parentheses. So now we get to use our algebra. Y prime is equal to, well, the derivative of x cubed plus 1 is 3x plus 0, 3x squared plus 0 times 2x minus x cubed plus 1 times, well, the derivative of 2x is simply 2. And all of that is divided by 4x squared. I squared it out. Let's keep going. So I have y prime is equal to, well, the 0 doesn't really count, so it's equal to 6x cubed minus, well, I have to distribute that, put it in brackets here. I have 2x cubed plus 2, again, over 4x squared. So I have y prime is equal to 6x cubed minus 2x cubed minus 2, distributing my negative sign there, don't forget that, divided by 4x squared. So I have y prime is equal to 4x cubed minus 2 divided by 4x squared. And I decided to simplify that a little bit, taking out a 2 from the numerator, so it's 2 times 2x cubed minus 1 divided by 2 times 2x squared, so I can get rid of that 2. So I have y prime is equal to 2x cubed minus 1 over 2x squared. So at x equals 1, the slope, that is my derivative here, is going to be 2 times 1 cubed minus 1 divided by 2 times 1 squared, which is going to equal 2 minus 1 over 2, which is equal to 1/2. So now I have found the slope of my tangent line. And the next thing I need to do is find out what the point possibility is. So my point is at x equals 1. So I'm going to substitute 1 into my original function to find out what is the point on the xy axis of that function. So I would have 1 cubed plus 1 divided by 2 times 1. Well, that gives me 2 over 2. So my point is going to be the point 1 for the x, and 2 over 2, 1 for the y. So I have the point 1, 1. Now here's my slope. My point is the point 1, comma 1. Using the point-slope form of the equation of the line, I have y minus y1, that's y minus 1, is equal to my slope times x minus x1, which is also 1. So y minus 1 is equal to 1/2 x minus 1/2. Add 1 to both sides. Y is equal to 1/2 x plus 1/2. So this is the equation of the tangent in slope-intercept form. But honestly, as far as I'm concerned, this is also the equation of the line in point-slope form. And unless it's specified to put it in a particular form, I think point-slope form is as good an answer as slope-intercept form. So I'm not going to make a big deal out of that. You might have to put it in slope-intercept form to find the same answer as the book, but this is a perfectly good answer for me.